How does your video call reach another country in seconds? The person who invented optical fiber was truly a genius. We know that light travels at the fastest speed. That's why sending information through light is the most efficient method. But we also know that light travels in a straight line, and if an optical fiber bends, the light could escape and scatter into the air. In reality, it's impossible to make optical fiber perfectly straight. So, how does light travel through it? First, understand that when light enters a different medium, it bends because of the difference in refractive index. For example, a pencil placed in water looks bent. This is refraction. Light also has an important property. If you change the angle of incidence, the refracted ray's angle changes too. When the angle of incidence goes beyond a certain critical value, the light doesn't escape. It bends back completely inside. This is called total internal reflection. Using this principle, light can be trapped inside an optical fiber and sent over very long distances. Optical fiber is made of glass, which is very delicate, so it needs a protective layer. But this protective layer is opaque, which blocks total internal reflection. Engineers solve this by adding another glass layer around the core, with a lower refractive index made by mixing certain materials. This allows light to travel smoothly inside the fiber. Now, how does optical fiber send information? Imagine you want to send a message to someone abroad. First, the text is turned into binary code, zeros and ones. These numbers are sent as electromagnetic waves to the nearest mobile tower. The tower changes these signals into light pulses. For example, bright light might mean 1, and dim light might mean 0. By changing the light's brightness, the entire message can be sent. This light travels through optical fibers, sometimes going halfway around the Earth to reach its destination. There are about 1.5 million kilometers of optical fiber cables under the oceans and underground. When the signal arrives, it goes to another mobile tower, which sends it to the receiver's phone, where the binary code changes back into text. This whole process takes less than a second. Pictures and videos, which are more complex patterns of zeros and ones, are sent just as fast using the same method. But over distances longer than 100 kilometers, the light signal becomes weaker. That's why repeaters are placed at intervals to boost the signal. For underwater cables, these repeaters get power from a copper layer inside the cable. The glass core of the optical fiber is as thin as a hair, but with all these extra layers, the whole underwater cable is as thick as a human arm.